Hello guys, in this video we're going to do questions 11 and 12. Number 11 wants us to solve for b, where number 12 wants us to simplify the expression below as much as possible, leave no negative numbers under the radicals, and no radicals in the denominator. Excuse me. Alright, number 11. Solve for b. We have a equals to 1/6 times the quantity in parentheses b plus c minus d. The first thing I want to do is I want to get rid of that 1/6 being multiplied to the outside. To eliminate the product of a fraction, we can multiply both sides by the reciprocal of that fraction. The reciprocal of 1/6 is going to be 6 over 1, which is just 6. So we can multiply both sides of the equation by 6. On the right side, I'm going to put it 6 over 1. So, on the left side, we have 6a equals to, well, the 1 on top simplifies with the 1 in the denominator. The 6 and the numerator here simplifies with the 6 in your denominator. So you're left with just b plus c minus d. To get b by itself, we're going to subtract both sides by c. Make that a little bit thicker. So subtract both sides by c. And then we're going to add d to both sides. So the c's is gone. D is also gone. And we're left with 6a minus c plus d equals to b. Or b equals to 6a minus c plus d. All right. Let's transition into number 12. It wants us to simplify. Leave no negatives under the radicals. Leave no radicals in the denominator. All right. So here we have the square root of negative 60 divided by the square root of negative 10. Now, when we have negatives under our square roots, that refers to imaginary numbers. If you remember right here, that I equals to the square root of negative 1, and I squared equals to negative 1. So if there's a negative under your radical, you can take the negative out from under the radical, and that becomes an I on the outside of your term. So what I'm going to do is, for the first one for 12, I'm going to do it the complete process, well, the numerator, and then you can see what I mean. I want to separate the negative from the 60. And I can use the rules of multiplying radicals. If you have multiplication under one radical, you can transform that to the multiplication of two radicals with the same index. So when it comes to the square root of negative 60, I'm going to separate that into the square root of negative 1 times 60. Square root of negative 1 times the square root of 60. The square root of negative 1 is I. So that's going to equal to I square root of 60. As you just see here, I could have just took the negative sign outside of the radical and it would have been the I. And I'm going to do the same thing for the square root of negative 10. I'm going to write that as I square root of 10. I divided by I simplify each other out. When you're dividing two radicals with the same index, that can be the division. It will be one radical with division under it. Basically what I'm saying is the square root of 60 divided by the square root of 10 could be written as the square root of 60 over 10, which is the square root of 6. All right, let's move on to the next problem for 12. Once again, take the negatives outside of the square root, and that becomes imaginary. So it's going to be I square root of 5 times I square root of 20. Let's multiply like terms. I times I is I squared. The square root of 5 times the square root of 20 is the square root of 100. Once again, I squared equals -1. So that is going to be -1 times the square root of 100, which is going to be 10. What number do you multiply by itself twice to get you 100? That is 10. -1 times 10 is -10. And that is the solution to the second problem for number 12. All right, guys. Hope you guys understood it. Hope you enjoyed it. Hope it made sense. Please remember these rules up here. I is the square root of -1, and I squared is equal to -1 when it comes to imaginary numbers. I'll see you soon.